Good morning also from my side. I'm glad to be here and mostly to have a supplementary talk on what Kozal has just made and expressed and show you what we do in Renesas. I'm going to try to a little bit narrow down the applications and mostly to the area and those that we have available today here for you to demonstrate, and they are allocated outside. So I'm going to make a quick introduction, mostly to refresh and tell you about the advantages of the edge AI applications and technology. And then I'm going to explain the 3 demos that we have prepared for this event. First is the asset movement recognition, which is a reality AI-based solution. And people and head detection, that is more like a computer vision task that is that we have done together with one of our partners, and of course voice user interface that relies on voice commands and voice recognition. So looking on the advantages, and many people talk about it already, and it's something that definitely we see in our side, and those are obviously reduced latency. Latency because we don't have to transfer data to the cloud, or everything is processed locally, and that gives us real-time performance, allowing to have real-time applications, and that also can improve the cost efficiency, but also the power efficiency, and at the same time bring security and privacy. Privacy because the data remain local, you don't have to transfer them, there's no way somehow someone to store them, and all of these are private. An additional part of that is on-device learning that is really ongoing right now in terms of technology, and something that's growing and allow us really to have small devices able to learn up to a level. And with all this, creates new capabilities and novel applications that could be used, could be implemented over the system, and allows customers to create products and us as users to enjoy them. So let me quickly go to our first demo at asset movement recognition. It's a real-time, it's data analytics. So the demo collects data from a sensor that carries an accelerometer and can detect kind of movements. And like drop, like a snake, like rotating, whatever. And we do have it in the outside area, implemented in the RA6M3 device, which is an ARM-based processor based on the Cortex-33, able to run up to 200 megahertz. And you can see the table, the RAM usage. But in the same device, in the same application, for a different device, we can go down to our 16-bit processor, the RL78, and you can see the pros and cons on that device. Obviously, the amount of data that the application covers is much less for a small system, but the inference time grows and it scales up quite a lot as we move on. The way to do that and how we implement it is by using the tool set from Reality AI. Kozal already explained that, and that allows to have kind of AI explore, meaning understand what is the application, what is the kind of data that you want to have, how to collect the data, because that's also important. Collecting data is the most important part, otherwise the model will never know what exactly you do, or even if it knows, it might not be taking the right decisions. And that drives us then on the hardware, and mostly on the BOM optimization, because data have to be collected by the hardware. And which hardware, which sensor, what device will be used. And through this process, it's giving the ability to the engineer to select and experiment with different applications, different systems, different devices, until it concludes on the most useful for the system. And of course, useful means data accuracy, system accuracy, but also the cost. That's why we refer to the bill of material in that case. And that gives us the data readiness, which in fact allows to understand what exactly the system is doing, how well those data are implemented, and moving forward to creating the model, understanding the operation, and deploying that to the device. There are optional features as well, like add-ons, like using MATLAB or collaborating with MATLAB and other external tools for collecting that. In order to give you a little bit of sense how it looks, and this is how it will be looking inside the tool. So on the top, you can see on the AI Explorer a number of data sets that have been selected, and how those data appear in a kind of representation that engineers can read is shown on the bottom graph. And then all the process is following. So I'm going to go to the next one. That's the computer vision task about people and head detection. The operation and the features are more like detecting a person or more person that stands in front of a camera, and allows to have indoor, outdoor applications, and selecting more people that are partially occluded can be detected as well. And that drives an operation that we have a trained data set of more than 30 million images that allow us to have this model running. And because we're talking about vision task and we're talking about single core devices, in this case, we're implementing that to the device that is to our new family, our new product in the Array family, which is based on the latest processor from ARM, the Cortex M85. And I have added those kind of comparisons between this CM85 and the M7. And for the same application, it's just 3 frames per second that the M7 can achieve, while we can grow to 13 frames per second when we're using the CM85. And all this inside the tiny footprint of less than 1 megabyte in RAM memory. How we do that? We collaborate with our partner Plumerai. Everything starts from a model that has been designed in TensorFlow, and has reproduced a library, TF-Lite library from microprocessors. Then we're reusing the inference engine that our partner has developed, and with that we can string the system in order to be able to fit inside the device that I have explained. Moving forward then to the voice user interface and part of the voice applications that we have. Why that kind of user voice application is important? It's obviously it's human-centered, and voice interface are the technology that allow us to communicate with the device without really using our hands or connecting or touching the device, or even creating more complicated environment. And that allows to have natural interaction with the system, with the environment around us, which makes it user-friendly and allows to have interaction with devices that could make our life easier. And that is also personalized, so allows us to talk to the device and communicate with the device in a way that we like, and the device knows about our preferences and specialities. And also multitasking and multimodal interaction is possible by creating additional tasks like keep the voice, but also use sound event detection, or even have other kind of applications, even include vision into the system and move forward. For that, we have developed a number of applications and development kits that are a kind of palm-size devices, where they support the lineup of devices starting from the Array 2 up to the Array 6. And in fact, talking about the Array 2, and this is the demo that we have outside, is the smallest device available today in the market, in the worldwide market, that can do voice recognition or voice command recognition. And this is based on ARM Cortex-23, one of the smallest parts of the family, and runs just to 48 megahertz operation. What we do and what we support over that, and what we have available today, is voice command recognition, is voice activity detection technology that allows the device to wake up when there is voice coming into the system. And by using that, we can control and reduce the overall power of the system, because when there is no reason for the device to operate or to make recognition, then just go to sleep. And when voice appears, it will wake up. And consider that to the device that we're talking about running at 48 megahertz, so small system can still wake up and recognize the voice, recognize the word that has been sent. And of course, text-to-speech is also another feature that we have available in terms of creating voice prompts into the system. What comes next is most on the audio front end and the natural language understanding, which will be supported on larger devices, of course, by increasing the naturality of communicating with the devices. With that, and getting to the conclusion, and I have shown you about real-time analytics, vision, computer vision, and voice applications that we have outside for our demonstration. The way that we do see that, and a bit of showing again all the flow and the areas where we are active and we are able to support products with a service package, with development tools, and of course with an ecosystem in order to create and provide application examples, toolboxes, and solution suites that support all the lineup of our devices, starting from the RZ, one of the high-power computing devices that we have, going to the RA, which is the ARM-based devices, RH, RX, and RL78 was more like custom-based devices, starting from 32 bits operation down to 16 bits operation. And with that, the lineup of the applications can be on build automation, home automation, agriculture, transport, and other known applications that we have. Wrapping up and ending my presentation, these are the 3 demos that we have outside, just to remind you, and come by our booth to experiment and explore them. Is the asset tracking that detects movements through an accelerometer, is the people detection, a computer vision task that detect people, and of course voice control, where we can enjoy the operation of a light bulb running on the small RA2 device. And with that, thank you very much for your time.